Okay, YouTube, in this video we're going to be exploring how to multiply complex numbers, but specifically complex numbers that are written in trigonometric form and not in standard form. Of course, we're already familiar with multiplying complex numbers in standard form. That is, like if we had some a plus bi times some other complex number c plus di, we could go ahead and carry this out. But what happens when we have two complex numbers such that they are written in trig form? So let's go ahead and take a look at this situation here. We're going to look at multiplication only, but the multiplication theorem basically says let there be two complex numbers, and we'll call these complex numbers z1 and z2, and they are defined thusly. That is, z1 is equal to some absolute value 1, or r1, so this is our modulus, and then we say we have theta 1 on both of these, which represent its argument, or its direction that it's heading in, whereas z2 has an absolute value of r2 and is heading in this theta 2, which is this other direction, okay? But if we define these complex numbers thusly, then we say then the product of z1 and z2 would of course be the product of these things right here. And that's, I hope what you see I've got written out down here. But we say r1 cosine theta 1 plus I sine theta 1 times r2 cosine theta 2 plus I sine theta 2. The idea here is this. According to the multiplication theorem, what it says is we can actually just take these two moduli, the modulus of complex number 1 and the modulus of complex number 2, and we can just multiply those together. And then we're going to take those times this value here, cosine theta 1 plus theta 2 plus I times the sine of theta 1 plus theta 2. So essentially, what this theorem allows us to do is this. It says if we were going to multiply two complex numbers that are written in trig form, all we need to do is this. We just need to multiply the modulus of each matrix, or sorry, each vector together, and then we're just going to add the arguments. So that's exactly what I write here. It says this theorem indicates that when we multiply two complex numbers written in trig form, we can just just multiply the absolute values, or the moduli, out front and get the new modulus, and just add the angles of the arguments. So what I want to do in this video is this. We're going to kind of run through some examples of really quick trig form problems to do with products, but it says use the multiplication theorem to find the products of the following complex numbers written in trig form. Also draw a rough sketch of the resulting vector. So you notice that we have these three complex numbers here. We have z1, z2, and z3, and they're all written in this trig form where we're given some r value or some modulus, so we say r, and then some argument here, some theta that tells us the direction we're heading in. So what we want to do on this first one here, letter A, is find z1 times z2. So if we're going to find z1 times z2, what we're really doing is we're taking two CIS 40 degrees, and we are multiplying this by z2, which is 4 cosine I sine of 10 degrees. And what we end up with, according to this multiplication theorem, is this. We just go ahead and multiply by the modulus by this modulus, and we get 8 is the resulting modulus. And then as far as what we get for an answer here, we're just going to take the two angles and add them together. So we get 40 degrees plus 10 degrees. And so we would get this new thing that is 8 CIS 50 degrees. Now, part of this task was to sketch what we get as a result. So this 8 CIS 50, really all this is some vector that's going in a 50-degree direction, which would be like just a little bit past 45. So like somewhere this way, and it is going 8 units in this direction. So when we say, what is this number right here, really all we're saying it is some number that when I write it, it is 8 units away from the origin, and it's proceeding at a 50-degree direction. So this would be the graph of our complex number right there. So let's try z1 times z3. Now z1 times z3 in this case, z1 times z3, we'll blockade this off here. This time we have 2 CIS 40 degrees, so 2 CIS 40 degrees, and we are taking this times this trig number in complex form, 3 CIS 120 degrees. In this instance, however, we would go ahead and multiply the two modulus values, and we get 6, and then we get CIS, and since we're multiplying these two things, we're going to add the arguments here. So this time I'm actually just going to add these together straight up, and I'm going to say that I get 160 here, and this would be our product, okay? So again, if we were going to sketch the product here, or at least what we get, we say that this is some number, this complex number, that is in a 160-degree angle with the positive x-axis. So we say this is the direction we're heading in here, and this is our argument, 160 degrees, and we are going 6 units out from the origin. So what I'm going to do is I'm going to actually draw this in, and why don't I put this in a different color here so that you can see it a little bit more easily. We'll put this in a blue. But we're saying I'm going to go 6 units away from the origin, if I can draw straight here, in a 160-degree direction. So we say r equals 6 is all this is telling us, and we're going 160-degree direction, so we'd say that this is the number right here, okay? And then last but not least, we'll do this last one here. What if I were to actually find the product of all three of these complex numbers together? So z1 times z2 times z3. And what I hope you can see is this. We could just multiply all the modulus values together. So we get 2 times 4 times 3 out front. So 2 times 4 times 3. And we would get CIS and the sum of all of the arguments or the angles here. So 40 degrees plus 10 degrees plus 120 degrees. And what we end up with here is this. We say 2 times 4 is 8 times 3 is 24. CIS, and 50 plus 120 is 170 degrees. So again, the very last part of this is I wanted to sketch what this number would look like. So 170 degree direction with the positive x-axis would be somewhere in this direction here. And we could sketch in this argument. So we say that this argument or angle is 170 degrees, and we are going 24 units out from the origin. So we just get to use our imagination here. We're going to label it actually. We say this is 24 because I said so, and that this is my complex number in standard form. There's our triangle right there. Okay. So in the next video, we'll talk about what's more convenient, doing these in trig form or doing them in standard